For today's lesson, we're going to go through 6.3, which is complex fractions and simplifying them. So we're going to recognize what a complex fraction is and then simplify them by doing a few different methods. All right? So we have some warm-up questions, which you should have done. If you have these done and you'd like to skip over them, please jump ahead in the video. But we'll look at these quick to kind of get our brains primed for what we're doing. So question 1, we're factoring, and we have a number in the front. That's our A value, so we have to do what I call SMILE method. For the front number, which is 4, we could try 2 and 2, or 4 and 1. For the back number, which is 6, we could try 2 and 3, or 6 and 1. Okay? And we have to get a combination so we can get that 5x in the middle. So let's try 4 and 1 and 2 and 3. I think that's the right combination that we need. So we need a 4x for the front, x for the back, and we'll put a 2 here and a 3 here. And then we can use this. That gets us an 8x. We got this. That gets us a 3x. So we can use those to get the positive 5x. The 8 must be positive. The 3 must be negative. All right? And that is the correct factorization. If we were taking this one more step, remember, if we had a equal 0 and solve, we would set this equal to 0, set this equal to 0, and we would get our 2 solutions. But we don't have to do that at this point. For the next question, we are simplifying 2 rational expressions. We're adding them. All right, so we have to get the same denominator here and here. And remember, we have to think of these as binomial pairs. We can't just add something or subtract something to the bottom. Okay, so we have to get the same pairs in the bottom. So on the left, we have the x minus 4. On the right, we have an x plus 1. So we need both of these binomial pairs in the bottom to simplify this one. So the one on the left is missing the x plus 1. Since we put it in the bottom, we got to put it in the top. On the right, we're missing the x minus 4. And the same thing applies here. We have to put it both in the top and the bottom. Okay? From here, we know the bottom will be this. Okay, so we know that on the bottom, we'll put this over here. We know our final answer is going to be x minus 4 and an x plus 1. The numerator is what we got to work with. So we're going to have to distribute here and FOIL here, and let's write those out. So on the left, we got 4x squared plus 4x. On the right here, we have x squared minus 4x plus 3x minus 12. Okay, that's my whole numerator. And now we just simplify that down and see what we got. So we have a 5x squared, and then we will have a 4x minus 4x is 0x plus 3x minus 12. Okay? And what we should do in the end is see if this factors. So you should double check, try your SMILE method to see if this factors, to see if anything cancels out in the end. So we would try a 5x and an x, and probably 3 and a 4. So 4 here gets me 20. That's not it. And we try a 3 here. That's 15 and 4. That's not it. We could try a 6 and a 2. 6 here, 2 here. That's 10 and 6. So this does not factor. Okay, so this is our final answer. And again, you don't have to FOIL out the bottom if you don't want to. I'm okay if you leave that. All right? So warm-up is done. Now let's look at the new lesson. Okay? So thinking back a long time ago, you guys have actually done stuff like this before in an Algebra 1 class, possibly a geometry class, where you take a fraction, okay, like 1/4, divided by another fraction like 3/2. Okay? Another way you could write this is simply like this, 1/4 divided by 3/2. And you should remember how to do something like this. All right? This is just skip, flip, multiply. I skip the first fraction, I flip the second fraction, and I multiply. Same thing we're doing up here. It's just written differently. So the way I like to write this is I say, kind of like our negative exponents, but a little bit different. I'm taking that bottom fraction and I'm moving it up. And when I move it up, I flip it. Okay, and then I'm just multiplying. Okay, so that's what we're doing. Right? Take this to the top, flip it, and then multiply it. Then when we multiply fractions, we go straight across. So this would be 2 over 12, which we need to simplify. which is 1/6. All right, and I probably should have cross-simplified here. But sometimes that gets a little messy when you're doing that because you're moving things around and you're canceling things out. So if you don't get that there, that's fine. Just get it in the end. Okay, simplify in the end. So what we're looking at here, all right, this again is the simpler version. We're looking at something like this, where we have variables in the numerator and denominator, kind of like where you're adding or subtracting, where you have the binomials or the polynomials or rational expressions. But we got a rational expression in the numerator and a rational expression in the denominator. And sometimes, like this one, you'll actually have to simplify those before you can move things around. Okay? So here are your rules. You want to find common denominators in the top and bottom. Okay? Separately, that's fine. And then you simplify each of the fractions. You simplify your fractions in the numerator, simplify fraction in the denominator. And then you skip, flip, multiply. That's what this is. All right? Multiply straight across and simplify. So those are the rules to simplifying something like this. All right? So looking at this one, we could get a common denominator here and here right away if you wanted to. But that might be a little more work because we're going to have to do it eventually anyways. We're going to have to simplify things down anyways, all right? So this is a single fraction in the denominator. So what we can do, and since it's a single fraction in the numerator, we can just do like what I did on the last example. Bounce this up, flip it, and then multiply, all right? And this one, since there's variables involved, it's probably going to be easier to cross-cancel. So I can't do anything with this or this because they are not the same binomial pair. They have to be exactly the same binomial pair or a variable in front to cancel things. But if I look the other way, this way and this way, I can cancel those out. So the 6 would turn into a 1, the 18 turns into a 3. And now we go straight across. So x plus 3 in your numerator, and then you have 3 times x minus 8 in the bottom, so you actually have to distribute that. Okay, and then you are done. All right, so it's not bad. Just flip the bottom, simplify things, and you're good to go. Okay, so next one down here. Same kind of idea. So we have a single fraction in the bottom, a single fraction in the top. So we're just going to take this, bounce it up, flip it, and then look to cancel things. So now we have the same binomial pair here and here. Those cancel out. And then remember how this works when you have a single variable and something like that where it's x squared. I can cancel out one of those variables just because it's a single x. So what do we have left in the numerator when everything cancels out? That would be a 1. And then everything except for the x canceled out in the bottom. So this just simplifies to 1 over x. Okay? That one's not bad. It's not bad when everything cancels out. All right, so now this is the second type of example I was talking about where you have to simplify in the top, and then if we need to simplify in the bottom, we can, but then we'll have to flip the bottom just like we did before. So step 1 is to simplify the numerator. And now we're back to how do we get common denominators? We got an x squared there and an x here. How do we get that common denominator? Well, since this is x squared and we have only an x here, I'm going to have to put another x on this one. All right, so this would be x on the bottom, x on the top, and then we're going to rewrite that after we combine it. So we'd have 5 minus 2x on top, and then we'll have an x squared in the denominator. So that's my top fraction. My bottom fraction is still x squared over 6, and now we have a single fraction in the top, single fraction in the bottom. Now we're ready to flip. So take this, move it up, flip it, and look to cancel things if we can, okay? So if we look this way, can't cancel anything. Look this way, cannot cancel anything. So it looks like we're just going to be multiplying straight across. So the 6 will have to distribute into that binomial there. So it would be 30 minus 12x over x squared times x squared is x to the 4th, okay? So that is our answer after we simplify that down. So that was kind of nice where we didn't have to simplify anything, but we did have to combine the numerator. All right? Same kind of idea down here. If you would like to give this one a try before you see the solution, please pause the video and then start it back up and you'll get to see the answer. All right? So, top, same deal. We got an x squared here, only an x here, so we need an x squared here. Multiplied by an x, and then simplify the top. So 4 minus 3x over x squared. And my denominator, x squared over 5, is already a single fraction. I don't have to do anything with that. And now we take our bottom. This is our skip, flip, multiply step. So 5 goes to the numerator, x squared in the bottom. Multiplying straight across, just like before. Then we have 20 minus 15x over x to the 4th. And there you have it. Okay? So we combined our numerator fractions, and then we did our skip, flip, multiplying step. All right. So we got a few more of these. If you wanted to try them before you saw the solution, go ahead and pause the video. Otherwise, keep rolling with it. So in the numerator here, we have just a single 1, and then over here we have a expression here that has the x plus 1 in the bottom. So we need the x plus 1 in the bottom of the 1, because remember, this is really like 1 over 1. So, and then down here, we already have things simplified, so we don't have to worry about that. So here, we need an x plus 1 in bottom, which means we also have to put it in the top. Okay, so we know our denominator is going to be the x plus 1. And then we add across the top. So here's one where we're actually going to have to add. Add those together. That's 11x plus 1. We're just adding like terms there. And then my denominator of the complex fraction is 11x plus 1 and x minus 1 on the bottom. So we're going to have to take our bottom fraction and flip it. X minus 1 over 11x plus 1. And I look to cancel out common factors. So that is the same as that one. And we can't cancel the other ones because one is a negative and one's a positive. So then we're just left with x minus 1 over x plus 1. And then you're done. All right. Moving on to the next one. So now we have something in the top and the bottom where we're going to have to combine by getting common denominators. So if it helps, put your single variables or single terms over 1. That might help you see what you need as the denominator here. Okay, so since I have a b in the bottom of this one, I'm going to need a b over here. So b in the bottom, b in the top. All right, since I have an a in the bottom of this one, I'm going to need an a over here. A there, and it might be helpful to rewrite this around so where it's A, B, not B, A, because alphabetical order is important with these. And now we got common denominators here and here, so let's put them together. We got AB plus 7 in the numerator over B, and in the bottom, we got AB plus 7 again. That seems kind of nice, over A. And now we are to the skip, flip, multiplying section. So take this, flip it up, multiply, or flip it around, and then look for things to cross cancel. So that and that cancel out, and we can't do anything with the A and the B, so we are just left with A over B. Okay? So we had to combine those fractions on the top and the bottom before we could do our skip, flip, multiplying step there. All right, so this next one, the next couple here, are a little more difficult, okay, because we have negative exponents with these. And so what the negative exponents are going to do, I can't take this and drop it down to the bottom here. I have to create fractions in the top and fractions in the bottom. So the first step would actually be to rewrite this where we have fractions in the numerator and denominator. So this would turn into 1 over A. This would turn into A over B squared. Okay? That's our numerator. So hopefully you can kind of relate this to this. We're just dropping numbers down below 1 or below the other term or variable to make it a fraction. And then we're going to do the same thing here. So we have an a over b squared minus, so now both of these are going to be under 1. 1 over a squared b. And now we have the step where we need to get common denominators. So in the top, we need an a and a b squared in the bottom of both. So that means this one is missing a b squared, and this one is missing an a. And when I put the a here, if I multiply by a on the top, that's going to make it an a squared. So we'll just kind of do that in one step. Okay? And then down here, we have an a squared b. And we actually need b squared. So we have an a squared because we take the highest power of each one of those. We have a b squared. So that means this one is missing a b. Okay? That'll make that b squared and b. That's the step to add the b there. And then this would be an a squared. And since we already have an a in the top, that's going to make that a to the third. Okay? So that was the step of getting common denominators for this group, and then again getting common denominators for that group. All right? Once we have those, then we can add across the top. Okay? So we have b squared plus a, and that might be better to write it out as a squared plus b squared. And then in the bottom, we have a b squared. Okay, so then this one, we have a cubed minus b. Looks like a 5. Let's change that to a 3. A cubed minus b over a squared b squared. Okay, so simplify numerator and denominator. Now we take this and flip it. So a squared b squared over a cubed minus b. And now we look to cancel things. So these, I can't factor or do anything with those, so I'm going to leave those. These, I can start taking out terms, or I can take out variables. So I have an a here. That's going to cancel with one of those and bring that down to just an a. Then the b squared will cancel with that b squared. So we're only going to be left with an a on the top there. Okay, so that's the only one that's left after I cancel things. So that's going to have to distribute through here because we are multiplying. So the numerator will be a cubed plus b cubed. Denominator, we have only left the a to the third minus b. Okay? So that one's kind of difficult. You might want to replay that one a couple times just to see how to do that again. But the first trick is actually changing these to a couple fractions in the top and a couple fractions in the bottom. Okay? And we have one more left. And this one shouldn't be too bad. It should be better than the last one. All right? So in the top, we already have common denominators. So we don't really need to do much except for subtract. So 6 minus 5 is a 1. X minus 5. So that numerator is done already. That was easy enough. Okay, my denominator, I have an x and an x minus 5. Remember, we have to have the binomial pairs. We cannot just subtract a 5. So this side needs an x minus 5. This side needs a single x by itself. So we're going to do this, x minus 5 on the left, and then just an x on the right. And I know that's not formatted the best down here, but it works. Okay, then I'll have my common denominator of x minus 5 when I'm done. If I need to distribute this, so that's, I'll write it down here, 3x minus 15, and then plus 2x. That's what we have in the numerator. So we have a 5x minus 15. Okay? We got things combined. Now we are flipping. So take this, move it up, flip it. And then cancel binomial pairs. So this will cancel with that, and that's the only thing that goes away. So we have an x in the numerator, and then a 5x minus 15 in the denominator. Okay? So to recap, we've figured out what complex fractions are. We've worked with complex fractions with a single thing in the numerator and denominator, and we've worked with complex fractions like this, where you have to combine the numerator and combine the denominator before you can simplify them, okay? So those rules again are back here. If you forgot them, what you need to do, and then if you need to replay any part of the video, go ahead and do that. Hopefully you enjoyed the video. So let me know if you have any questions. Thank you for watching.